It's 10 o'clock in Central Europe. Good morning. It happens with the best space missions. It happens all the time. Sometimes they must be delayed. 50 years ago, for example, Apollo 14 could not take off as planned. The lift-off had to happen 40 minutes and 2 seconds later. Sometimes it takes weeks, months longer to get a mission off the ground. Remember ESA's spectacular Rosetta mission, delayed for more than a year from January 2003 to March 2004, all for the sake of safety. So now we are on the launch pad again, 5 weeks later in the safety of a virtual event, like last year. And I finally can say the words, ladies and gentlemen, welcome to the 6th edition of the INNOspace Masters Conference and Awards Ceremony. My name is Klaus Krüsken and I'm honored to be your host again. On behalf of the German Space Agency at DLR and the INNOspace initiative, a warm welcome to all partners of the INNOspace Masters competition, German Aerospace Center, the ESA Business Incubation Centers, Bavaria and Northern Germany, and Hessen, Baden-Württemberg, Airbus, OHB, and DB Netz AG. A day with one motto: innovations for sustainable infrastructures in space and on Earth. Today is all about brilliant minds, innovative ideas, and new opportunities. You will meet all this year's finalists who are, at the same time, already winners. One of them will be the overall winner, to be revealed later this afternoon. Until then, we have inspiring keynotes, breakthrough ideas, and a man who is about to embark on his first mission into space. But now, I'm delighted to announce Dr. Walther Pelzer, member of the DLR Executive Board and head of the German Space Agency at DLR, to kick off the INNOspace Masters virtual event.
Dear Thomas Jarzombek, dear Josef Aschbacher, Mr. Lindetal, Mr. Bertling, Mr. Weiland, as representative of our sponsors, dear Mr. Reuter, ladies and gentlemen, it's a great pleasure to welcome you to the INNOspace Masters Award Ceremony 2021. Actually, we planned this ceremony in June as a hybrid session after we had a virtual session in 2020. But due to the fact that we have a COVID case in the team, we had to postpone it to July. And, of course, we had to set up this ceremony in a virtual way. Nevertheless, I'm looking forward that we will have a meeting, a hybrid meeting, or a meeting in person in 2022. Enough of COVID, let's go to the ceremony. INNOspace initiative. The INNOspace initiative was launched in 2013 as part of the German high-tech strategy, financed by the Federal Ministry of Economic Affairs and Energy. This initiative is supposed to cause transfer from space to other branches, to initiate innovation, and to inspire other people to come up with solutions which they actually can transfer from space or to move into space. This initiative has a lot of elements. The INNOspace Master Conference is only one part of it. It also has networks, it has exhibition, and also some parts how we actually try to attract young people for technology and science. When we came up with this INNOspace Masters Conference and with this award and this competition, we always have to look for some headlines. And this headline has something to do with innovation, of course, because we want to put invention into successful innovation. And it has to do something with the overarching goals of EU, of the German government. And having in mind the Green Deal of the European Commission, having in mind the Sustainable Development Goals of the United Nations, and having in mind the Nachhaltigkeitsstrategie of Germany, we came up with the idea to have innovations for sustainable infrastructures in space and on Earth. So both ways are important. I'm absolutely sure that you are aware of the situation and the principle of spin-in and spin-offs. Nevertheless, I would like to introduce two two examples, or actually three examples, of very successful innovations we had within our competition in the recent years. The first one is one from Deutsche Bahn, from our sponsor Deutsche Bahn, where we actually have the combination of space data, satellite data, data of unmanned aircraft, and a combination of artificial intelligence analysis to create something, I would say, preventive maintenance. When you are coming from production, you would call it preventive maintenance. It's just because we all suffer when Deutsche Bahn is delayed or sometimes has to rule out and cancel lines due to the fact that after a thunderstorm or tornado, we see that railways are blocked for trees or other reasons. And with this setup, with this data, this company, ESA, is creating, based off the satellite data from the aircraft and analysis by artificial intelligence, they actually can boil down this data to one single tree and identify one single tree which cause a hazard and cause maybe a blocked railway, and to prevent this happening of a blocked railway before it occurs. So it's a huge, huge step in regard of being more precise, being more in time with just connecting data from space, from air, with artificial intelligence. Another one, the other way around, it's more a case, let's say, in regard of spin-in, is that we use coatings which were developed for other reasons with multifibers, carbon multifibers, to actually create, on the one hand side, lighter products and products which are possible to suffer actually or to stand higher temperatures. So actually we are able with this product to create higher combustion temperatures and be more efficient by the combination of ceramics with multifiber, carbon multifibers. Another one is actually the, let's say, best way if we not only have one-way tickets, spin-in or spin-offs, if we have more or less some kind of technology platform which goes back and forth between different areas. And this is actually the so-called INNOs. I'm positive you heard about it. It's a technology we let's say, broadcast and we talk about for quite some time. It's a technology which was used and invented for application on Earth. It was actually used to identify bacteria, for example, in surgery rooms and other rooms which are very sensitive for bacteria. It was then transmitted to the ISS and actually to do the same over there. But then they moved the next steps. They used this technology to actually go and use just breath to identify whether or not some astronaut might be ill and whether there's bacteria or other illness involved. After this invention took place, this invention was also moved back on Earth. Now we have actually the development to use these INNOs in the COVID issue. Not only COVID, actually it was already started before, that we can use these INNOs to identify just by analyzing the breath of a person whether this person is ill and what kind of illness this person might have. And this is something we use now on Earth and also in the identification of COVID-19. And we are positive that this technology, and this is the reason why on the slide is fourth with question marks and fifth with question mark, will see some other application in other areas as well. The INNOspace Master is not a single tool. I mentioned already that it's one element of an initiative. It's actually a combination of this competition with networks. We are financing with the national program. That's the reason why we have this tech of the national program. We have networks for agriculture, for motion, and for health. Very successful networks, because if we want to create transfer, we need to get these people, we need people get together and talk with each other and discuss issues they have. But on the other hand, and this is what we have together with our colleagues from the ESA point of view, from ESA, is that we are also in contact with business application centers. So if we move, and we have actually a lot of examples, if we move innovation from our INNOspace masters to the application, to a successful startup, we actually can move it into the business application center. And it will be supported by so-called technology brokers, which create contact to the market. And of course, with the new EU Cassini program from the Commission, we have additional ways for finance it. So the system is a whole value chain to actually foster startups from the idea to the startup, from the pre-seed to the startup to the successful company. This is what we are doing, and now it's actually time to thank the people who made this event possible. First of all, Franziska Zeitler and her team, Mr. Hahner, for example, who are absolutely ambitious to make this event happen. They are not frustrated by backdoors like COVID. They were willing to put it into practice. I would like to thank our sponsors, Airbus, OHB, and Deutsche Bahn. And I would like to thank also Mr. Rudolph from ZOF for their support in organizing this topic. So this is what we see up to now. And here we have an absolutely ambitious program. We will see some very interesting keynotes. I'm proud, actually. I'm actually proud that Josef Aschbacher, the new Director General of the ESA, will take his time to join us and give his keynote. The same with Thomas Jarzombek. He will give a keynote as well. Of course, a video like this one. And later on, we will have with Mr. Reuter some very interesting information from the World Economic Forum. I wish you a very interesting conference, and later on a very, very, let's say, tensing celebration for the winners of the award. Thank you very much.
It's going to be an exciting day. Thank you, Dr. Walther Pelzer. For Austria, 2021 has been a year of writing history. For the first time ever, an Austrian national soccer team advanced to the round of 16 at the European Championship, and that's how far it went. 5 weeks ago, when we were supposed to have this event originally, there was still hope for more. More promising, for the first time, an Austrian is leading the European Space Agency. Dr. Josef Aschbacher became the ESA Director General on the 1st of March, 31 years after he began his career in ESA in 1990 as a young graduate at ESRIN. And now he's here to tell us how to advance a sustainable new space economy in Europe. Let's hear which goals he plans to score.
Hello, and I'm really happy to give this keynote to you about fostering a sustainable new space economy in Europe, and I'm very glad to be invited for this keynote. I would like to thank the organizers of INNOspace, in particular DLR, and show you some of the activities which we're doing in ESA in this domain. Let me go to the first slide, and you see here a slide of Agenda 2025. Agenda 2025, as you know, is the agenda for an ambitious Europe in space. Of course, it has the ESA logo on it, but it is really an agenda for all of us in Europe who are investing in space and to really see where we are. But before I go into details on some of the Agenda 2025 priorities, let's step back for a moment and compare Europe with the rest of the world in space. If you open the newspapers, if you watch TV, in space you hear a lot of stories from the US, Elon Musk, Kuiper, Amazon, Silicon Valley, but also NASA about the achievements they have. And that's great. I'm very happy to see big successes and big activities happening in space in the US. In China, exactly the same. If you hear the news, you hear that Chinese taikonauts have gone to the space station. made in China with a Chinese rocket and staying there doing research for Chinese technology and activities. That's great, and I'm really happy to see that also China is building up a very strong presence in space together with the US, together with Russia and many other countries who are active involving. So my question now is, where is Europe in this race which is taking place in space? And this is really at the heart of Agenda 2025, to see where Europe stands in space, how Europe wants to use space for its own purpose, for its own people, for its own society, but also as a world economic power to establish and to remain at the forefront in order to not lose out and not be thrown out of this race. And this is at the core of Agenda 2025, to make sure that Europe has an ambition, is formulating its ambition for space for the next decade. So therefore, looking at Agenda 2025, you have to project yourself into the next 10 years, 2035 as a reference period, and to see what does Europe want to have at in the next decade, in 2035 or beyond. And then, based on this, in order to get there, of course, you have to set your priorities for tomorrow in order to build the future. And this is at the core of the priorities which are listed in Agenda 2025, which you see listed here on this slide as the main topics where ESA wants to engage itself in order to raise the ambition for space in Europe. Number one, the ESA-EU relationship. This is core because the European Union has a very strong space program which it just launched. The space regulation has been finalized. The FFPA has been signed between the European Commission, ESA and EUSPA. And the European Commission has put a strong program on the table to support the main flagships, Galileo and Copernicus, plus a number of other activities. Then, of course, you have the European Space Agency with its cycle of funding activities every 3 years on average through ministerial conferences. And these two entities, of course, ESA as the Excellence Center for Technical Engineering and Science, and European Union with its strong political weight, but also funding of its flagships. These two entities in Europe have to closely work together with the member states of ESA and of the European Union, like Germany, but all the other member states, to create a coherent, strong European vision for space. And this is at the core of meeting the ambitions of the future. Number two, commercialization. I don't need to mention Elon Musk or Jeff Bezos or some of the other private persons investing in space, but immediately it is clear that the investments in the commercial sector are very strong outside Europe, and the question is, what can Europe do in order to meet some of these challenges? Safety and security is another example where, again, we need to see where Europe wants to go in terms of investments of space. Then you have program challenges. Program challenges means to look into some of the activities of where ESA is engaged. Launches is a good example. Satellite communication is another one, where we have huge challenges worldwide, but also in Europe, and we have to realize new activities and new programs. And obviously, last but not least, ESA transformation, to see where ESA as an agency needs to go in order to be more dynamic, more responsive, in order to meet some of these challenges which were ahead of us. Now let's go into some of these aspects in more detail. What you see here is commercialization as an issue, where we really have to realize that, for example, in the US, in 2019, we had 5 billion investments from the private sector in space. In Europe, in the investment of SMEs, for example, we had 188 million, so less than 10%. And this, of course, shows immediately that the commercialization of space is proactively, very dynamically put forward and pushed forward in the US through Silicon Valley, but also through private investors like Jeff Bezos, like Elon Musk, or many other people. And that's a reality. And my question is, how can we in Europe achieve a stronger involvement of the commercial sector in space in order to really combine public investments with private investments and create major activities, major flagships involving also the private sector? And this is a huge challenge. We have a lot to do compared to other countries, and this is something I really would like to work together with the member states in achieving. There's many things that need to be done. Liaisons and partnerships with funding entities, venture capital companies, with angel funding bodies, with the European Investment Fund, with the European Investment Bank, but also other funding institutions that are interested in space as a growth sector and where they can make future businesses work and being successful. And the space sector is a very fast expanding element of the economy. For example, today we expect the space sector to be worth about $300 billion in 2040, according to Morgan Stanley. This will grow to $1 trillion. So really increase a lot in different segments, especially in the downstream sector. And this is an element where we would like to really participate and shape the sector also from the European side. One example where we do this very successfully already since a few years is called InCubed. InCubed is a program initiated in Earth observation, but we have similar activities in telecom and integrated applications or in other domains of space in ESA, where private industry is coming with a proposal to ESA, and we co-fund with the funding of member states an initiative that is proposed and is initiated by industry in a country or several industries in the country. A very successful program where we really want to nurture new disruptive ideas. They are of smaller scale, there's not huge funding that is required, but very successful to create new ideas, disruptive innovation on the case of individual examples where ESA expertise is merged with industry's willingness to invest and taking risk in order to make new inventions and new discoveries. Another example where we really invest significantly in the near future is also on communication. On the left side of this slide, you see the geostationary satellites. They are all around like a ring around our planet in 35,800 kilometers height, geostationary orbit. And you see a lot of them, obviously, over different geographic areas. And they have been, for the last few decades, the cornerstone of satellite communication. On the right-hand side, you see the future evolution into lower Earth orbit in order to reduce latency, but also address broadband internet as a major domain. And here constellations are built up, again, driven by the US. We have Starlink being built up with thousands of satellites being launched. We have Kuiper in the starting block ready to be built up. We have other initiatives in China with, again, very high numbers of satellites being designed as part of a huge constellation. And in Europe, we have OneWeb as one initiative that is launching satellites and is building up a constellation. OneWeb will be operational in its first generation by the end of this year, but also other constellations are being built up. Thierry Breton, Commissioner in charge of space in Europe, has proclaimed that Europe needs to invest and really speed up and gear up its energy in secure communication. And we as ESA, we are working together with the Commission in providing cornerstone elements and R&D and technology developments in order to help the Commission and Europe building up a constellation on secure connectivity. Of course, it will serve a purpose of providing broadband internet for different users, partially government or commercial users. It is most likely a combination of public and private initiatives serving different users, but also using terrestrial and space assets at the same time. And in space, different assets in geo orbit, in MEO orbit, and in LEO orbit. And this is a program which we are putting together with the Commission right now in order to build up this constellation. Again, on secure connectivity, a bit to underline what I was mentioning, that this is a partnership which we would like to provide, where ESA provides one element of this overall architecture. We are working very closely here with the European Commission, and the European Commission has invited or is inviting industry to come with different proposals. This is all work in progress, and we are working with our means in order to establish this constellation. Then we have another example, again, where the commercial aspect is very strong. It's called Digital Twin Earth, or the Commission has launched a program called Destiny, where where the Earth observation data on one side are used on a routine basis, and we have the best Earth observing system in the world today through Copernicus and the other Earth observation programs. So you have a constant flow of Earth observation data, which is coming, but which is combined with Earth system models, geophysical models, to model and understand the various aspects of our planet Earth, how it functions from an Earth system point of view. Artificial intelligence is a very important element that comes into it in order to model some of the aspects, and the use of supercomputers or high-performance computing is a grid that is necessary in order to do all this computation that is required. So this really is a combination of Earth observation from space, of observations on the ground, in the atmosphere, in the oceans, of models and artificial intelligence using high-performance computing to allow to simulate situations on our planet and to simulate what-if scenarios. What would happen if I change a parameter? What would happen if sea level rises by half a meter, by 1 meter within the next decades or by the end of the century? What are the consequences for people on the ground, on coastal areas, but also what are the consequences of climate change as a consequence of activities on the ground? And all these what-if simulations can be done with a digital twin, Earth, which we are developing and building up as one of our activities together with the Commission, but also as a proposal, as a forthcoming proposal at the next ministerial next year, 2022 in ESA. Then space meets digital transport. This is another example where space means are used for transport on the surface, for car for transport in particular, and what we can achieve with better management of our transport fleets, either individual cars or trucks or ships, that we can reduce through an optimization of the routes. We can reduce CO2 emissions by quite an important factor of 10 to 15%. And this is quite important in order to also contribute to the goals of the Green Deal, where we want to reach carbon neutrality by 2050, and space is a very important element that can contribute to this political agenda and political goals. Another example of sustainability, but in a different place and a different dimension, is really in space. Sustainability in space, meaning to avoid space debris, or if there is space debris, get them out of the orbit in order to make sure that there is old or outdated or non-functional spacecraft or rocket components taken out of orbits that are used by our satellites. What you see here is ClearSpace 1, which is a mission, a satellite that has an arm that grabs another object in space and literally takes it away from an orbit into another orbit and possibly going down into the atmosphere and burning up. And this is really something that cleans up debris in space, very important for sustainability in space, and this is something that is quite important for space safety and space traffic management, which we are building. The satellite will be launched in 2025 and is quite unique, and not only from what it does, but also the way how we procure it, because here we procure a satellite, a service, where we said through an ITT that we offer a certain amount of money for somebody who removes a space object, and the winning proposal was this ClearSpace 1 proposal, which we are developing together with industry right now. Then let me spend a minute on the business incubation centers, which are a very successful element of ESA overall in Europe, but in Germany we have particularly large participation and a very enthusiastic participation by SMEs in these various centers. So altogether in these different big centers in Germany, we have more than 300 startups that participate, creating more than 4,500 jobs, high-tech jobs, to use space data, convert them into information which are then sold on the market. The turnover is in the order of 200 million for the year 2019. And the amount of venture capital that has been attracted through these SMEs working with us and on the ESA business incubation centers is quite significant. It's about 500 million euros over the last 5 years, which is very significant and really helps creating an ecosystem of startups and companies that is investing in space, which is a very fast evolving segment of our economy. And with this, I really would like to thank you for your attention. It was a pleasure to present to you virtually these slides, and please come back to me for questions by email or in other means, and thank you once more for your attention.
There's a lot going on in Europe. Thank you very much, Josef Aschbacher. And now, from the German federal government, a gentleman whose job description couldn't be better targeted for the INNOspace initiative in its two most important aspects. He's the federal government coordinator of German aerospace policy, check, and he's the Economic Affairs Ministry's commissioner for the digital industry and startups, check. This is exactly what comes together in the INNOspace Masters: space, innovation, startups. Ladies and gentlemen, Thomas Jarzombek. He will tell us about the importance of innovation-driven space economy for Germany.
Ladies and gentlemen, I am delighted to be here today with you. On the one hand, because of the extremely exciting idea pitches of today's finalists, which fascinate me really every year. On the other hand, because INNOspace Masters initiative itself is an important instrument for fostering the innovation landscape and ecosystem of the German and European space industry. We are all aware of how important innovations are for global competitiveness. This is especially true for a country like Germany, with an economy heavily based on world-leading technologies. And it is especially true for an industry that is undergoing a radical change, like the space industry. New companies are entering the market, and we see a shift from few large institutional funded players to many smaller and maybe scaling private companies. This is a major change in the structure of an entire industry, and also has an impact on the emerge and implementation of innovations. And therefore, the space industry is kind of a test bed for all other fields of research and development. The task of the BMWI, our ministry in such phases, is to create the right framework conditions so that innovations can continue to emerge and German companies can still become and remain technological world market leaders. These efforts are reflected in the financial expenses provided by the federal government to tackle the challenges connected to that goal. The federal spending on R&D within the aerospace industry at 1.8 billion euros in 2019 is the second highest compared to all other sectors. Only the healthcare sector is ahead of that. Additionally, the federal government set the goal to increase the investments for R&D activities from currently 3.1% of GDP to 3.5% by 2025. These investments are used to enable initiatives such as INNOspace Masters. Innovation means not only new development, but also market success. And I want to stress that very much, because in the past we have been very successful in R&D, but to say this from a German perspective, we have not been global leaders when it came to the market success and to the implementation of our ideas and R&D results in products and services. And so the INNOspace Masters promotes both the new developments as the market success perspective. And what does that mean in detail? We must not forget that when we talk about innovation, we are not only talking about technical new developments such as quantum technology, laser communication, AI-based analysis, software, blockchain technologies, and so on. The second and compelling component is the market success. I want to repeat that. Of all these developments, a technical development that has been developed without the market in mind, or that does not even have a chance of being commercially successful and therefore is not used, is of little value. We want to create ecosystems here in Europe where the people can provide from. So, in addition to new ideas, we must also support the market entry. These are two different challenges that must be considered separately. With its 5 different challenges, the INNOspace Masters targets both of these aspects. At an early stage, the DLR challenge looks for novel technologies with a low degree of maturity, which commercial application is not initially in focus. Technical developments, especially in the space industry, are associated with high development costs, which return on investment can only be expected after years. Therefore, the DLR challenge offers extensive funding to enable the development of radically new approaches. At the same time, pursuing new and unconventional approaches also means a high risk and a high probability of failure. Competitions such as the INNOspace Masters are a good opportunity to test one's idea at an early stage and to fail in a positive sense. I mean, failure is not a good thing, so it's not so connected in Germany as a good thing. But in the end, we have to go for risks, and not everything that we are trying to get steps on new ground will be a success. That's obviously clear, and so that's what we may mean when we say fail in a positive sense. In most cases, the first idea will rarely be the best and the right one. And a good example of this is the team from the University of Bremen, second place in the DLR Challenge 2019. The team had submitted ideas to the INNOspace Master several times, which were not among the winners. However, these ideas were further developed and adapted by the team until they were able to convince the jury with their idea in 2019. Currently, the team is successfully implementing a ferrofluid-based thermal management system for satellites with an R&D project with a volume of 400,000 euros, funded by the prize of the DLR challenge. So it is important not to see the failure of an idea as something bad, but to develop and to adapt the idea until the right approach is found. Besides the development of new ideas in the first step, the commercialization of these approaches is also a major challenge in the second step. With the ESA Big Challenge, the INNOspace Masters offers an opportunity for a 2-year incubation program embedded in an excellent network, as well as the access to venture capital. Both are important components to be able to compete in the market. In 2020 alone, the incubates of the ESA Big Bavaria acquired 380 million euros venture capital. Furthermore, the challenges of the industry partners Airbus, OHB, Deutsche Bahn Netz AG also offer to young companies a great opportunity to work together with global players and thus establish themselves in the market. At the same time, the BMW is launching other initiatives to support young space companies to access the market. For example, a few weeks ago, a workshop was held together with space startups and the space agency to discuss supporting conditions that are necessary for startups in Germany to grow into the global market. The outcome of such workshops can be the possibility to support startups with letters of intent issued by the space agency, which helps to gain first customers, or changes in the framework of public tendering processes that allow also startups to apply for public contracts. And that's also very important, these public contracts, because I believe innovation can only be fostered when the government and the state is going ahead and procuring more and more also at startups and at innovations that are really disruptive. Another example is the current micro-launcher competition, one of my favorite babies, when I may say that in this way. The aim is to give young companies the opportunity to develop their launcher systems to a maturity where a commercial launch can be offered. Through the competition's prize money, the BMW acts as an initial customer and gives the 3 companies in the competition the chance to gain additional customers and other sources of funding. And what we also learned in that competition is that because of the price, the beginning, the 500,000 euros we have spent on startups that we have checked with the DLR really in detail, this was something that helped very much to gain venture capital, because a lot of venture capitalists outside, they're interested in investing in tech, in space, but they cannot really say if what the team is going for is really proven and if they are capable of doing what they pretend to do. And this is a role I believe that it's very important for the government and also here for the future, a key driver. So at the same time, through providing the funding as a competition prize, we can ensure that the startups have to push their technologies very fast in order to be ahead of its competitors. To sum it up, innovations can only emerge with competition, either through competition in the market or through innovation competitions, such as we have seen this in the micro-launcher competition. The INNOspace Masters competition has confirmed this over the past years. Since 2015, over 530 project ideas have already been submitted by over 1,200 participants. I'm convinced that today's pitches will underline that not only the numbers are remarkable, but also the quality of the ideas. Therefore, I'm looking forward to the first pitches today, which will be presented by the DLR Challenge finalists. Thank you very much and all the best, and I'm looking very much forward to see all these innovations fly.
Inspiring words from Thomas Jarzombek. Thank you very much, and we will see you later because you will later announce the overall winner of today. But now, virtual drum roll, it's time for the creative minds of the INNOspace Masters and their impressive ideas. 5 challenges await with 3 finalists each. Sustainability was on the minds of all our participants. There were hardly any limits to their creativity. So we're in for 15 excellent concepts that are fascinating, each in its own right. Let's start with round 1, the DLR challenge. The aerospace industry is in transition. Spin-ins and spin-offs, the transfer of technology and know-how from other sectors into the aerospace industry and vice versa. All that offers great opportunities for innovation. The DLR challenge is looking at technology developments prior to commercialization with a special focus on cross-industry cooperation projects. The challenge of the German Space Agency at DLR is looking for innovative ideas and concepts leading to improved technologies, processes and applications by transferring expertise between space and other sectors. The topics are digital sustainability, of course, and security in space, resource-saving approaches in space and on Earth. And here is DLR Challenge Team 1. Alexander Hilgard, Sergei Montenegro and his team from the Julius-Maximilians-Universität in Würzburg. They will introduce us to Tomoplex, which is a sensor film to monitor structures during flight and under a load. Reusability is the keyword here.
Hallo, mein Name ist Alexander Hilgard von der Universität Würzburg.
Grüß Gott, ich bin Sergio Montenegro. Mein Lehrstuhl ist Aerospace Information Technology in der Universität Würzburg.
Unser Beitrag für den INNOspace-Wettbewerb ist eine Sensorfolie für die Überwachung von Strukturen. Tomoplex steht für tomografischer Plexus und gibt mit seinem Namen einen Hinweis auf die Funktionsweise. In der Luft- und Raumfahrt ist Wiederverwendbarkeit ein stark aufstrebendes Thema. Wiederverwendbarkeit ist aber nur möglich, wenn wir den Gesundheitszustand einer Komponente wissen. Und das geht nur durch kontinuierliche Überwachung.
Tomoplex ist eine künstliche Haut, fühlende Haut, womit wir Veränderungen erkennen können, ob es einen Kratzer gibt, einen Stoß oder zu hohe Kräfte.
Wir verwenden eine Folie als Träger für elektronische Messtechnik. Die Folie vermisst nicht sich selbst, sondern die Strukturen darunter. Es ist also ein direktes Messverfahren. Mit dem Auffolieren erhalten die Strukturen eine funktionale Schicht. Aktuell bleiben bei Kontrollen im unbelasteten Zustand auf dem Boden vorhandene Fehler in den Strukturen oft unentdeckt, weil sich beispielsweise Bruchkanten wieder perfekt ineinander fügen. Mit Tomoplex lassen sich jedoch im Flug und unter Belastung Messreihen durchführen und solche Fehler entdecken.
Und das ist eine super große Hilfe für Wiederverwendung von Strukturen. Wir können on the fly messen, ob etwas sich verändert hat und ob wir Wartung durchführen müssen, bevor wir nochmal starten. Und dadurch sparen wir uns sehr komplexe Testverfahren hier auf dem Boden.
Team 1. And here is already Team 2 from the Institute for Applied Physics of the Friedrich Schiller University, Jena. Dr. Tobias Vogel will explain QVEX, which is a quantum processor for encrypted communication with satellites.
Novel quantum technologies of the 21st century promise unconditionally secure communication, exponentially larger computational power, as well as compact and yet more precise sensors. Many of the quantum systems that are under investigation, however, are only application-specific and not compatible with each other. There's no unique material like a quantum silicon as we use it for electronics. With the QX project, a universal quantum processor will be developed. This processor integrates the entire architecture from the quantum light source to the detection system in a compact optical circuit. The key feature is that it can be universally programmed just like a computer chip for different applications. Special focus of the project will be the secure communication with satellites, as the QVEX chip can be used as a light source for quantum cryptography. Unlike conventionally used laser-based systems, the chip can transmit quantum information during daylight, meaning that every satellite pass can be used and not only those during the night. In addition, using quantum light, the data rates can be enhanced drastically. In the long term, also end-user devices like smartphones or computers could be equipped with such a chip. Therefore, we are addressing the exponentially growing quantum market. This includes, for example, flexible use as a secure random number generator, as a sensor, and of course, as a login node to a quantum-secured internet. The project is located at the Friedrich Schiller Universität in Jena and the CIS Forschungsinstitut für Mikrosensorik in Erfurt. This allows us to fabricate this future standard component with a local supply and value chain.
And now meet Jan Gerschig. He's representing DLR Challenge Team 3 from the Fraunhofer Institute for Environmental Safety and Energy Technology, Spaceflow, a concept for energy security for satellites and space stations in their isolated places of operation.
Good afternoon. It's a little dark in here, isn't it? Let me just fix that. Much better. And pretty easy on Earth with the high availability of energy. But in space, when using nothing but solar power, it's a bit more complicated. In space, we need reliable energy storage systems to ensure a high energy safety, especially during periods of darkness when orbiting. With Spaceflow, we want to pave the way for high energy density flow batteries in space, which are eco-neutral, non-flammable and non-explosive, which have a very high cycle stability and a long service life, as missions for exchanging batteries are very resource intensive. The special feature of Spaceflow is the integration of the long-lasting and high-power flow battery cells directly into the supporting structures of space stations and satellites. This means that the batteries can take on several relevant tasks at once, which can result in a crucial gain of efficiency. The battery cells are not only storing energy, but also stiffen the modules, support the thermal management, and may even absorb radiation. The Spaceflow cells can be integrated in cylindrical modules like this astonishing realistic model of the Columbus Lab, but also in cuboid satellites and even geodetic domes. So let's make orbiters and space missions safer as well as more resource efficient and sustainable. Go for the flow.
Jan Gerschig. These were the first 3 of 15 fascinating ideas in today's INNOspace Masters Awards, the DLR Challenge. And now we move on. So many more exciting ideas, concepts, projects to come. Here's the second round of finalists, those of the ESA Big Challenge. With the European ESA Business Incubation Center network, ESA has supported over 1,000 startups in the space sector to date. The German ESA Business Incubation Centers, BICs, offer the only startup program in Germany that promotes company foundations based on technology transfers from and into the space sector, from the initial phase up to the marketable product. All of that in close collaboration with renowned partners, DLR, Fraunhofer, Airbus, Bosch, T-Systems, Ariane, OHB. The program in Germany supports young companies for a period of up to 2 years, with great success. ESA Big companies in Germany have raised more than 400 million euro venture capital in 2020. The ESA Big Startup Challenge of the INNOspace Masters was looking for new technology transfer ideas and business models from Earth into space and vice versa. Potential examples: mobility applications and solutions, innovative optimization solutions, increased efficiency and customer orientation solutions, components or subsystems, or any other ideas in the space sector. And here is ESA Challenge Team 1. Markus Witt from Metrom Mechatronische Maschinen GmbH with a small processing system for manufacturing and repairs, which can adapt to the environmental conditions and always creates the optimal result with the lowest possible use of resources. Sounds fascinating and has a cute name, Sissy.
Dear ladies and gentlemen, I am representing the company Metrom, and we have been founded in 2001. Meanwhile, we are managed in the second generation. We are delivering special machine solutions on the basis of patented parallel kinematics, and we deliver them worldwide with 60 machines in the market meanwhile. We are getting rid of a problem of having several machines for several processes, because we combine all processes in one hybrid system. This system can be used for additive and subtractive machining of metals and plastics. So 3D printing and machining in one system. And even though we have the possibility to use this system mobile and can set it from one position to the next, and size of the workpiece doesn't matter. And to bring this to the next level, we created a new innovation which is called the Small Mobile Machining Center. And the Small Mobile Machining Center is lightweight, is consisting of repeatable components, and is self-calibrating. And therefore, we make additive and subtractive machining possible directly on Mars and Moon, as easy like ordering parts on Amazon. Thank you.
Moving on to ESA Challenge Team 2, Jorge Ramirez Miguel, represented by Alfredo Martinez for JMP Ingenieros SL. They introduce us to Micro-G-Scope. It's an innovative approach to the problem of biological testing in space, using a fluorescence contact CMOS microscope and a special growing chamber in a CubeSat.
Hello, my name is Alfredo Martinez. I am here to present the Micro-G-Scope project that is presented to the INNOspace Master Competition. This is an international group that contains 2 teams from Spain, another from Ireland, and another one from Germany. And the goal of the project is just to provide enough research capabilities to test whether different drugs can be used under space conditions. To do that, we want to design and test a microsatellite that is going to be containing a full cell biology laboratory where cells are going to receive different treatments, and one of the microsatellites is going to be flight into space, whereas another laboratory is going to remain back on Earth. Different challenges like creating the right microscopes, the right laser chambers for the cells, and also the final goal is just to produce a service that is going to be a high value, reduced cost, and very versatile service for both drug companies and research institutes as a fraction of the price that nowadays is being paid, for instance, for tests run at the International Space Station. I hope you like the presentation, and I thank you all for watching. Thank you very much.
Thank you very much. And we move on to Team 3 of the ESA Challenge with Katarina Ostaszewski and her team of Finalists GmbH. Finalists stands for an Intelligent System Maintenance and Current Monitoring. Based on space technology deployed as part of ESA's Rosetta mission, Finalists developed a contactless, non-invasive and easily retrofittable sensor solution for current measurement.
Hi, I'm Katharina from Finalists, and this here is our sensor for intelligent system maintenance and current monitoring. Metrology and innovative measurement technology are essential prerequisites for digitalization and sustainability for both industry and consumers. Existing systems based on an inductive measurement principle require access to every single conductor in a cable. Because of this, these systems are demanding, complex, costly to install, and cannot be used flexibly. This can make it expensive or even uneconomic to potential customers. We from Finalists have developed a system for contact-free current monitoring based on space technology. Our system can monitor the current in a fully insulated cable after the sensor is fixed, for example, with cable straps. Our solution uses spatially resolved magnetic field data to determine the current in each conductor of the cable. This technology is a direct descendant from scientific work as part of the ESA Rosetta mission previously done by our team. It can be used for intelligent system maintenance, load management, consumption monitoring, or smart building technology. Irregularities can be classified by variances in current waveforms. Then possible faults like bearing damages or electric motor failures can be detected timely. In short, the Finalists sensor system offers an easily retrofittable solution for current monitoring and predictive maintenance based on space technology, paving the way for future smart energy systems.
Finalists, and that concludes the ESA Challenge participants. You want more? We have 6 so far, 9 more to go, 9 more finalists at the INNOspace Masters. But before we go to them, the screen will go to somebody else for a few minutes. You've all heard the great news. In December 2020, Dr. Matthias Maurer, German ESA astronaut, was officially selected for his first mission to the ISS. The mission is called Cosmic Kiss. That means, he says, a declaration of love for space. But there's more to it, as you will find out in a moment. He will be the second ESA astronaut to fly as part of the NASA's Commercial Crew Program. He's scheduled to launch this fall from the Kennedy Space Center in Florida as part of SpaceX Crew 3, together with NASA astronauts Raja Chari and Thomas Marshburn. Matthias Maurer studied in 4 countries. He has a passion for travel, and doing all of that from outer space, research and travel now only seems logic. He's currently training for his mission. Please welcome Dr. Matthias Maurer.
Dear participants of the INNOspace Masters Conference, dear finalists of this year's competition round, I'd like to greet you all from the United States. When you are watching this video, I'm in Houston to get prepared for my first mission to the International Space Station. Therefore, unfortunately, I cannot attend this conference in person. Nevertheless, I'm glad to participate via this virtual message because innovation competitions like the INNOspace Masters are very important. Also for me as an ESA astronaut. My journey to the ISS is only possible thanks to the transfer of knowledge and know-how from other industries into space, with innovative technology developments and with the commercialization of these technologies. As an astronaut, I highly rely on innovative technologies which enable a safe stay on board of the ISS and which also enable pioneering research in space. The fact that I will be the second European and the first German astronaut who takes off with a Crew Dragon capsule from SpaceX is actually a good example of how commercial-driven innovations can make a change in spaceflight. So we really need people like you who are fostering new technologies and pushing these innovative approaches into real products. Furthermore, my liftoff from the United States underlines the importance of international cooperation, especially for human spaceflight, but also for space industry in general. I'm happy to see that the INNOspace Masters gains increasingly relevance internationally, which is a very important development. I've noticed that this year, project ideas from more than 20 different countries were submitted, which is quite impressive. I hope this trend will further increase within the next years and maybe some international joint projects among INNOspace Masters participants even arise from this. Because we do not only need to learn from other industries in the sense of a spin-in project, but we also need to collaborate internationally. But besides the growing internationality of the competition, I would also like to emphasize another point of today's conference: innovations for sustainable infrastructures. That's the overall topic of this year's competition round, and it puts sustainability explicitly into focus, which I highly support. My first mission to the International Space Station is named Cosmic Kiss. On the one hand, this expresses a declaration of love to space itself. On the other hand, it includes the need to respect, protect, and preserve the nature of our home planet and to contribute to a sustainable future. Seeing the world from the ISS, seemingly small and alone in the endless space, probably puts every astronaut in a new perspective and raises the awareness of how vulnerable and unique our planet is. Therefore, I personally take my mission and research I will conduct also as a duty to contribute to a sustainable future on Earth. During the half a year in space, I'm scheduled to contribute to around 100 to 150 experiments in various research fields. But for keeping the possibility to carry out research in microgravity in the next decades, spaceflight itself needs to become sustainable. And I think there are reasons to be optimistic about that. With a planned operation until 2030, the ISS will sum up to 30 years of continuous research in space. So in my eyes, the ISS already is a good example for sustainable infrastructure in space. At the same time, there is a given need to permanently develop new concepts to maintain the running systems for enabling a safe operation in the future. I'm happy to see that in the past competition rounds and also the projects among the winner teams certainly addressed these challenges. Therefore, I would like to thank you all the participants, for their engagement and their innovative mindset to foster new ideas. And I want to encourage all teams to believe in themselves and to pursue their projects. I wish all the best to the INNOspace Masters participants, and I wish you all an exciting and fruitful conference and award ceremony today.
Matthias, Maurer, all the best for your mission from all of us here at the INNOspace Masters. And you mentioned sustainability. That leads us right to our next keynote speaker, whom you might very well meet in Davos, or as it was the case this January, virtually at the World Economic Forum conference. The World Economic Forum has one mission: to improve the state of the world by engaging business, political, academic and other leaders of society to shape global, regional and industry agendas. And that includes space. One keyword for making the world a better place is, of course, sustainability. But how do we measure sustainability in space? Not by looking at the carbon footprint. There's another way. Timothy Reuter, head of Aerospace at the World Economic Forum, will talk about the current benefits and challenges of space, and he will introduce us to the concept of a space sustainability rating, while at the same time keeping his own carbon footprint low. By the way, he did not board a flight to join us here in our live studio in Oberpfaffenhofen. He taped his keynote at home in New York City.
Good afternoon. My name is Timothy Reuter, and I am the head of Aerospace at the World Economic Forum. The World Economic Forum is the international organization for public-private cooperation, probably best known for our annual meeting in Davos, Switzerland. We live in an incredible period in history when it comes to understanding the universe. Space is just 100 kilometers up from the ground upon which we walk every day. Beyond these 100 kilometers, space is vast. This year alone, no less than 3 missions from different countries arrived at the Red Planet, 2 of which made successful landings and whose rovers have started exploring. One of these launched a drone for the first time ever on another planet. There are 2 international collaborations that are planning to bring humans back to the moon over the coming 10 years. It has been also 60 years since man first flew in space, and constant human presence in orbit has been normal for 2 decades now. In the past few weeks, we've seen the beginning of a new age of space tourism that will finally grow the number of humans that have ever been to space beyond triple digits. These are just a few key developments out of many. And I don't have to mention to all of you the growth in Earth observation, global positioning, and global connectivity programs. The benefits space has given us, and it is important to underline, is yet to give, are tremendous. This is fantastic and should be exciting for all of us. However, there is a but. We are running the risk of putting in danger this very access to space if we do not start taking better care of the orbits around the Earth, particularly the low Earth orbits, or LEO. As LEO is getting more and more crowded, close to 1 million pieces of dangerous debris, larger than 1 centimeter in size, pose a significant threat to valuable assets such as satellites and space stations, and of course, to human life. The immediate safety of astronauts, infrastructure, and the long-term sustainability of orbits overall is threatened, as any such debris has the potential to destroy any of the current missions in these orbits. There are close to 4,000 active satellites in orbit today, and this number is rapidly growing. These orbits are also critical as we need to pass through them to the destinations beyond, such as higher geostationary orbit, Moon, Mars, or beyond. The concept of the Space Sustainability Rating, SSR, originally conceived by the World Economic Forum Global Future Council on Space, has been in development over the last 2 years by an international consortium of partners: the World Economic Forum, the European Space Agency, and a joint team led by the Space-Enabled Research Group within MIT Media Lab, with collaboration from Bryce Tech and the University of Texas at Austin. The SSR itself aims to provide a new, innovative way of addressing the orbital challenge by encouraging responsible behavior in space through increasing the transparency of organizations' debris mitigation efforts. The rating will mark operators on elements such as following international standards and guidelines, approach to avoiding collisions, data sharing, ability to verify the information provided, post-mission deorbiting maneuvers, and even how well they can be detected and identified from the ground. The choice of orbit they operate in and whether the launch vehicle used to deliver their satellites was left in orbit also would impact the rating. Bonus marks will be given for adding current optional elements, such as grappling fixtures, for possible future active debris removal mission to avoid satellites being stranded in case they cannot be deorbited under their own steam. The idea is that availability of such a rating creates peer pressure and a desire among actors to be able to get one, but also not only to get a basic rating, but rather strive to get the best rating possible. As the overall space community becomes more mindful of sustainability, this allows for differentiation and quick identification of responsible actors. This in turn will give an extra point to compete on, instead of just performance and price. In the future, when the rating is established, one could imagine that insurance providers, financial actors, regulators, and customers will prefer to work with or give advantage in their relationship to an actor that has a good rating. In the future, the rating could also evolve and offer a chance to launch providers to have their own rating based only on the launch vehicle, and organizations could receive a corporate rating perhaps based on their missions overall. Now the project has entered a new phase as the project consortium, supported by the advisory group, have selected EPFL Space Center, ESpace, at the Swiss Federal Institute of Technology Lausanne, EPFL, to lead and operate the SSR going forward. The team has started the transition already, and we should see the first formal ratings being issued as of early 2022. While SSR in its current form looks to encourage more responsible operations of active missions to reduce debris creation, another element that needs to be considered is actively removing the debris that is already there and which risks colliding with other debris or with active satellites. For space, we need to think of the right financing mechanisms to pay for removal of debris. Think of climate change, and the analogy is eerily similar. We have to shift our societies to emit less greenhouse gases, while also work on solutions: tree, carbon capture and storage to remove CO2 from the atmosphere. If we think even broader, we need to also worry about ensuring that all the active objects in orbit operate safely. And that requires coordinated measures and rules of the road that are adhered to and respected by all operators. Autonomous systems of different organizations need to be able to talk to one another. We need to have a better understanding of all the debris that is in orbit, and we need to have a unified, accepted international approach. With all these elements, we find ourselves in the realm of space traffic management, which also needs to be addressed in parallel to dealing with debris. This is why the Forum is launching a new initiative on STM that will bring together key actors to work on practical, tangible, and impactful solutions to help address the global challenge of STM. Through our neutral multi-stakeholder platform, we'll be able to drive this work forward with the leadership of industry and in collaboration with key policymakers and civil society experts. We look forward to working with you all on tackling this global challenge. Thank you.
From the World Economic Forum, Timothy Reuter. And now we're back to our challenges. 3 more challenges to go, 9 brilliant concepts. It's time for the Airbus challenge. With new commercial approaches, Airbus is positioning itself as a European leader at the pinnacle of technology and industrial development. Airbus welcomes the opportunity to find external innovators with this award to shape the future of commercial space together along the complete value chain. Let's be more specific. Airbus was looking for exceptional hardware, industrial processes, applications, or business models with relevance for space that can have a lasting influence on our daily lives. The focus was on solutions enabling sustainable infrastructures on Earth and in space on a variety of topics. Among them, mobility and transportation, 5G connectivity and IoT M2M, agriculture, life sciences and health, microgravity sciences and material research, and new and sustainable technologies and services. Let's begin with Airbus Challenge Team 1. Niels Helzet represents DigiFarm AS. DigiFarm, a concept for detecting the world's most accurate field boundaries to power precision agriculture. Let's give farmers better ideas, better data for better decisions.
Hi, my name is Nils, and I'm one of the co-founders and CEOs of DigiFarm, and we're an ag tech startup based in Norway. And we started this journey back in 2018, and my journey starts a little bit further back as I'm a 15th generation farmer in Norway. And the reason why we started this is because when you look at precision ag services and in-field analytics, it all has to start with accurate field boundaries. And right now, we don't have that. Right now, it's controlled by cadastral map data. In Norway, we have something called AR5 from NIBIO. In the EU regions, you have something called the LPIS. In the US, you have common land units, which are common land units are over 13 years old, and field boundaries do change over time. So this data becomes outdated and accurate. So one big thing that we looked at is the ability to deep resolve Sentinel-2 data from 10 meters to 1 meter per pixel resolution and increase the georeference to sub-meter accuracy, and use this as a composite to be able to build a deep neural network model, which can automatically detect field boundaries and seeded acres. And so far, we've managed to do this quite successfully. We've done over 50 million hectares in the US, Canada, Australia, Germany, Norway, Italy, and Spain. And we started marketing in November of last year. And since then, we've secured 23 pilot projects with B2B and B2G clients across the world in 30 plus regions. We also have a business model, a SaaS business model, where we charge per field boundary or per hectare per year. And luckily, I have a pretty good team around me. And there's myself, and I also have Konstantin, who's our CTO and co-founder. I also have Alex Melanchuk, who used to be the global head of digital technology at Xarvia and Bayer. I also have Josef, who has a lot of experience with multispectral data and remote sensing. So thank you so much for listening. I hope you enjoyed it, and hope to join you on this journey together. Thank you.
Thank you. Frank Koch will now represent Airbus Challenge Team 2. He comes from Orbit Recycling. Alreco is his concept, Orbit Recycling's new composite material for sustainable moon explorations. Humans are heading back to the moon, and they need something better than moon dust as construction material.
My name is Frank Koch, and I founded Orbit Recycling to bring sustainability to space. Together with the research group around Julian Barsch, Stefan Linke, and Professor Stoll, we developed a process for aluminum casting in regolith. This enables the production of large objects on the Moon from space debris. Last year, we started developing Alreco, a mix of aluminum and regolith. This material has significantly better material properties compared to pure regolith. In particular, we were able to optimize the thermal conductivity and heat capacity, as well as the tensile forces. Alreco is ideal for heat storage systems on the Moon to heat large volumes with sunlight and use them as energy source during lunar night. Our melting and sintering technology is extremely light and requires no external energy, but uses only sunlight and Fresnel lenses. And our process technology for aluminum casting and regolith in Alreco production is simple and can be optimally automated. With the support of DLR, Germany, with its sustainability industry solutions, could become the leading country for space debris recycling and lunar building materials. I would be pleased if the INNOspace Masters would add further research institutions and industrial partners in order to further improve our material and develop additional application scenarios. Thank you for your attention.
Also competing for the first place in the Airbus Challenge is Team 3, Clear Sky Vision, led by Morten Fjord Pedersen. He will introduce a versatile approach for cloudless optical satellite data. That means clouds are blocking the Earth, blocking the view, along with shadows. It's the most limiting factor in Earth observation. Here is a solution.
Hi, I'm Morten from Clear Sky Vision. I have the pleasure of presenting our cloud-free approach for more consistent optical data. On average, 70% of the world is clouded, which is why cloud masks usually are a must-do job. But when encountering persistent cloud cover, actions derived from satellite imagery will always be outdated. Most optical satellites are also somewhat incompatible with each other, and it can be inherently difficult to make a service work on many different satellites to mitigate this problem. Even within the same satellite constellations, we see inconsistencies. The solution is clearly a world without clouds, at least in the digital format, and a cloudless solution that can bring consistency and reliability. We're building a foundation for up-to-date continuous monitoring, a clear view of Earth that is easier to work with. Imagine a data funnel where all unusable data is removed and the remaining usable data is condensed into one format, the exact format you are used to work with, whether it's Sentinel-2 or more specifically Sentinel-2B to avoid fluctuating values. Artificial intelligence has a unique capability to work with much more data than you and I could ever wrap our heads around, but the versatility also extends into the output format. In our optics, the only way synthetic cloudless data can bring value in its original format is with all relevant spectral bands, keeping the benefits of multispectral imagery and its unlimited use cases and possibilities for end-user creativity. Thank you for your time and have a great day.
And now you know the 3 finalists of the Airbus Challenge. We move on to the OHB Challenge. The OHB Challenge encouraged innovative and creative ideas to create new impulses for space. Overall, OHB aims at ensuring long-term sustainability in space while increasing the performance in all future space projects. Here's the challenge. OHB was seeking for new ideas for a more sustainable future space sector, from novel concepts to competitive solutions. Ideas and concepts for cost reduction and the efficiency in the manufacturing of future space systems. Here we're talking robotic systems, automation, power systems, etc. Also, technologies for better use of the space infrastructure. For instance, applications and services based on space technology, cryptographic technologies, cloud operations, cybersecurity. And ideas for commercialization of space, exploration, experiments, and any other inspiring idea in the space sector that might contribute to a more sustainable space business. So, meet Challenge Team 1 in the OHB round. Christian Stamper will talk about a sustainable spacecraft propulsion by water as the expellant mass. Water is abundant in the solar system. It can be found on the Moon, Mars, the icy moons of Jupiter, and on smaller celestial bodies such as asteroids. Why not use it as a propellant?
Hello, my name is Christian. I'm a mechanical and aerospace engineer, and I'm participating here as a private person. I would like to tell you about a topic that excites me very much. It is the idea to use water as a propellant, or better said expellant mass, in a space propulsion system. As we know nowadays, the solar system is awash of water. Water is found everywhere, and it's a key factor for the further exploration of the solar system. Accordingly, it is conceivable to make use of it directly in a thruster. In general, it's simple. Take the water, heat it to steam and then to plasma state, and expand it in a nozzle. The hotter it gets, the more mass efficient the thruster is, and what makes it really hot is a microwave generator. This idea is not new. About 30 years ago in the US, first thrusters were developed, and the combination of microwave and water showed very promising results. But they never made it to space. However, microelectronics has evolved since then. The efficiency of amplifiers, miniaturization, and new type of solid-state microwave generators are available. And this makes a reassessment of such a system absolutely reasonable. Water-based propulsion would have many advantages. Cost saving, it's a greased propellant, easy to handle, and could be used on a wide range of applications. I would like to conduct research to that topics in the frame of a PhD thesis, and I'm very grateful to come that far in this contest. Thank you very much.
Thank you. And now meet Ignaty Romanov-Chernigovsky from DLTEO company, the one-stop shop for Earth observation data market. The Earth observation data product market will grow exponentially to become another full-fledged commodity market, yet there are two key elements that are currently missing from it. Easy-to-use interfaces that allow players in the industry chain to bypass specialists, and customizability of data processing pipelines. Here is a solution.
And today we'll be presenting to you a one-stop shop solution for Earth observation data processing and trading. Now, the Earth observation industry is changing rapidly. The volume of data and the demand for it are growing exponentially year over year, with new players entering the market and new generations of satellites coming online. It still, however, remains a market that is hard and expensive to enter, with a lot of high friction between existing market players. We provide a serverless, scalable, and decentralized data and algorithm exchange that is built as an open source platform where you own your data. We build a bridge between different Earth observation market players and lower the overall barrier to entry for new players. Finally, we also provide decentralized data processing and do-it-yourself data pipeline services. Our business model rests on charging a commission fee on every transaction that goes through the platform, as well as on the overall appreciation of the value of the token that is used as a medium of exchange on DLTO. Finally, similar to Red Hat and MongoDB, we provide premium membership services with additional features. Our current stage is we're in a pre-seed funding round looking for 550 to 850K. We are being incubated by the ESA Business Incubator Center in Austria. And within the next 12 months, we expect to complete our MVP. Within 2 years, we will be launching the full-scale platform, and we expect to hit financial break-even point within 3.5 years. This is our team as CV, and thank you very much for listening.
The team from DLTEO OHB Challenge number 2, and the third team is led by Niklas Wendel, the German network of young scientists, U-Forum, Debris, cleaning space at scale. We spoke a lot about debris already today. The ever-growing amount of space debris is a critical threat to the space industry and jeopardizes the essential services provided to clients all over the world. So now meet Debris, a small satellite for active debris removal.
There are many environmental challenges, and today I want to talk about the solution for one. My name is Niklas Wendel, and I founded the DevRes project. We are a team of students aiming to become a space startup, and are working on the DevRes Pro, our small-scale approach for active debris removal. Space debris has been a threat known for many decades, but today it's more crucial than ever. Our everyday life and research activities are depending on space-based technologies. However, the collision risk in Earth orbit is constantly increasing due to space debris, putting satellites and their services in danger. However, to this date, never any active debris removal has been performed. Projects currently under development are connected to enormous cost and are specified towards one specific target, preventing the possibility for widespread adaptations to thousands of possible clients. Therefore, we are developing DEFRIS. DEFRIS is a small satellite, and it's aiming at the solution of core scalability issues to provide space debris removal. Therefore, we are aiming to provide space debris removal as a service at a price point low enough to enable large-scale removal operations and put an end to space debris problem as once and for all. We want to do this to provide security and sustainability to the space industry, community, and all its associated services. So let's clean space at scale.
This concludes the OHB challenge. 3 finalists and now have 3 more, and our last challenge comes from the DB Netz AG, the infrastructure subsidiary of Deutsche Bahn AG. It operates the largest railway network in Europe, measuring 33,300 kilometers. It's 3 times as long as Germany's motorways. Who would have thought it? And I learned a new word. If its 120 million railway sleepers were lined up, they would almost reach the moon. What are railway sleepers? The bars that the rails are mounted on, German word Eisenbahnschwellen. Now let's look at the challenge. DB Netz AG is seeking for innovations from the aerospace sector that can be used to intelligently inspect, automatically maintain, and continuously monitor the current state of tomorrow's infrastructure, to make it more efficient, available, and robust. The challenge was looking for participants who aim to support the development of their technical systems with an eye towards achieving an intelligent, interconnected, durable, and disruption-free infrastructure. Participants had the chance to partner up with DB Netz AG and put their solutions to test in the company's working railway environment. DB Netz AG was looking for innovative solutions in the following areas: predictive maintenance technologies to monitor technical equipment, standalone energy supplies and data transfers for sensors and signaling equipment, rapid recording, transmission and analysis of large amounts of data across the railway infrastructure, materials that will increase the useful life of technical equipment, protection solutions against weather, aging or erosion of infrastructural elements, and digital models for mapping and simulating the physical infrastructure. That's a lot, and a lot of opportunities. For instance, for DB Challenge Team 1, Adrian Sosna from Hakaris Incorporation in Japan, AI-powered aerial image analysis enabling continuous monitoring of infrastructure and preventative maintenance. With a rapidly changing climate and the emergence of readily available satellite imagery, there exists both the need and opportunity to switch over from an interval-based to a needs-based approach for the maintenance of infrastructure assets. Hakaris Innovation helps enable this shift.
Hello and konnichiwa. I'm dialing in from Kyoto, Japan to tell you about our AI solution for aerial imagery-based asset maintenance monitoring. With a rapidly changing climate and the emergence of readily available satellite imagery, both the need and opportunity for turning maintenance of infrastructure assets from a intervals-based to a needs-based approach exists. Hakaris Innovation helps enable that shift. Current solutions for AI-based image analysis typically require large, well-defined data sets for creating AI models, which are difficult to collect. Hakaris solution is fueled by a proprietary sparse modeling-based AI engine. This powerful technology is uniquely adept at providing big insights from small data. This allows for an AI system that is able to adapt to changes over time and that can provide an instant bird's eye view of assets' current health. The human-centric design with functions such as heat maps of decay provides operators with actionable insights for smarter maintenance operations. To learn more, contact me at adrian@hakaris.com. Thank you.
Thank you, Adrian Sosna. Professor Florian Siegert and Sven Schmidt of 3D Reality Maps will introduce us to the concept of Team 2, the DB Netz AG Challenge, monitoring of traffic routes by a solar electric powered ultralight aircraft and with innovative multi-sensor 3D capturing and processing technology. You might not think of it as very important, but the vegetation alongside railroads and roads is important. It's critical to operational safety. Here is a way to have a good look at it.
Hi, it's a pleasure to be here. My name is Sven Schmidt. I'm from Electra Solar, and we design and operate solar electric aircraft for remote sensing purposes.
I am Florian Siegert, CEO of 3D Reality Maps in Munich. We are specialized in geodata analysis. Together with Electra Solar, we developed a new approach for railway infrastructure monitoring.
Storms regularly cause severe damages to the rail infrastructure of up to 60 million euro per year. The goal of our concept is to mitigate these costs by creating a predictive maintenance and damage avoidance strategy based on aerial imagery data. Our concept is based on the environmentally friendly solar electric aircraft Electra One that carries different types of sensors that allow us to address a multitude of different topics with a single flight. Compared to conventional aircraft, we're able to yield a much higher spatial resolution, and compared to drones, we're able to cover a much higher range.
Our goal was to optimize data acquisition and data processing in a smooth workflow that is almost fully automated. The capacity for data acquisition is now up to 400 kilometers of rails and roads per day. We use artificial intelligence to create a three-dimensional digital twin of the railway system, which helps to improve vegetation management and other tasks for infrastructure monitoring. Our technology is unique in terms of spatial resolution and range, and it is unmatched in costs and efficiency.
Thank you. And now to a team that you've already met. Finalists has also an entry in the DB Challenge. They are Team 3. Magnetic rail infrastructure monitoring is their topic. Digital rail infrastructure monitoring is vital for future rail mobility, especially for autonomous train operation. Knowledge of the exact position of, let's say, a switch is required at all times. Current systems don't work sufficiently. Here's a look into the future.
Hi, I'm Henriette from Finalists, and this is our sensor for magnetic rail infrastructure monitoring. As some of you may already know, digital and continuous monitoring of rail infrastructure is and will be vital for train systems and autonomous operations. No current system in use provides continuous feedback on the real position or movement of components. This often can lead to false alarms and track closures. In order to offset this problem, we have developed a digital rail infrastructure monitoring solution which provides this feedback and information. Our solution uses a monitoring sensor that is based on a high-precision magnetic measurement principle. It will monitor all relevant rail infrastructure components such as switches, switch drives, railroad crossing barriers, and signals. Data is transferred wirelessly from our sensor to the cloud. It is then processed by us and sent on to a signaling control center. They can then see how parts of the system are operating and/or whether they need attention. For example, a switch may not be completely shut when it should be. In short, the Finalists sensor system offers a monitoring service that provides more accurate digital and continuous feedback on system components, is easily retrofittable, and is maintenance-free.
And now you know them all, the ideas of our 15 finalists, lots of amazing ideas, all worthy of an award, and all will get one. But is it first, second, or third place? Do you have favorites already? Were there ideas where you think, well, yes, this is the best today? So who will be the overall winner? All to be revealed this afternoon after a lunch break. Unfortunately, other than we would have done it 5 weeks ago in Berlin, we cannot serve the lunch to you, but we give you enough time to order a pizza, check what's left in the fridge, Be ready for what's coming up because you want to be awake and alert and not hungry for this. At 1 o'clock in Central Europe, we will back with our awards. See you then. It's 1 o'clock in Central Europe and we are back. And I certainly hope you are too, because we have lots of good news and you should be ready for it. For our 5 challenges, we have 15 contestants, all of which are already winners. But who will land the top spot? Who are the runners-up? We'll find out for our 5 challenges. Let's begin with the DLR. The winners will be announced by Dr. Walther Pelzer, head of the German Space Agency at DLR, and Franziska Zeitler, head of Innovation and New Markets in the German Space Agency. She is the founder of the INNOspace initiative, and she has been a good spirit to so many participants and winners. And Philipp Hahner, the project lead at INNOspace for INNOspace Masters at DLR.
Ladies and gentlemen, after today's pitches of the finalists and the keynotes, we have now reached the last stage of the INNOspace Masters Competition 2021. The highlight of every competition, especially for the finalists, is the award ceremony and the announcement of the winners. But before we come to the award ceremony, I would like to give you some statistics about the competition. We had 330 participants from 23 countries. So we achieved a very, very big coverage of Europe and beyond Europe. We had 126 applications and business cases submitted. Very interesting from my point of view, and a sign for the success of this initiative is that only 80% of these applications were coming from the space sector. At the beginning, we had most of the applications coming from the space sector. That was by nature due to the fact that most people from the space sector were known to the space agency. But the success and actually the target was to get space connected to other branches. And having in mind that only 18%, I know I repeat this number quite often, but only 18% in this challenge were now coming from the space sector, it shows that Mrs. Zeitler and her team were very successful to actually address a very, very broad community. And another additional and interesting number is that more than 50% of the participants were coming from startups and small and medium-sized companies. So also here we have a very big coverage of the group we really want to address. So innovators, people who are at the beginning of their career, who are maybe in the seed phase, maybe just entered the startup phase, so that we actually can foster them with this initiative, with this competition, and to move them later on into, for example, an ESA Big center in Germany. Here we have some of the winners of the recent years. Since 2015, we had 1,220 participants. We had 72 winners, and you can see the icons of a few companies which are very well known, but a few which became very well known in the recent years. And I think this competition was part for this reason. After this brief overview of the competition, I do not want to keep you waiting any longer. Now it's time to turn the spotlight on the finalists and finally to announce the winner of the INNOspace Masters 2021. We will start with the DLR challenge. For this, I would like to ask Mrs. Zeitler to join me as well as Mr. Hahner. Both are from the Department Innovation and New Markets and responsible for the setup of this conference and, of course, for this competition.
Okay, we will start with the third place. The third place of the DLR challenge goes to Spaceflow of Jan Gierschik from the Fraunhofer Institute for Environmental, Safety and Energy Technology. Congratulations.
Thank you very much. Pretty nice. Thank you very much. Oh, also this. Let me thank you, the whole INNOspace team. It was a great pleasure to be a part of this innovation pushing competition. Thank you.
Dear ladies and gentlemen, now we come to the second place of the DLR challenge. The second place goes to Alexander Hilgard of the Julius Maximilian University Würzburg with the idea Tomoplex, a sensor film to monitor structures during flight and under load. Congratulations and good luck for your project.
Super! Großartig! Vielen Dank! Vielen Dank, das war großartig.
Okay, now it's time for the winner. And the winner is the first prize, and the winner of the DLR challenge is QVEX, Quantum Processors for Encrypted Communication with Satellites. Dr. Tobias Vogel, Institute of Applied Physics from Friedrich Schiller University, Jena. Congratulations.
Wow! Yes! Super! Wow! Cool. Well, it's a great pleasure and honor for me and the QVEX team. Thank you very much for the trust in our technology platform.
The DLR winners, congratulations also from us here, live from Oberpfaffenhofen. And now I am pleased to welcome you to the ESA Big Challenge 2021 award ceremony, which will be presented by the Business Incubation Centers of the European Space Agency in Germany. Dr. Frank Zimmermann, Managing Director at CESA GmbH, Zentrum for Satellitennavigation Hessen, and Thorsten Rudolph, Managing Director at AZO Anwendungszentrum Oberpfaffenhofen, will take over.
Germany is one of Europe's leading startup powerhouses, attracting 5.3 billion in venture capital funding in 2020, that nearly doubled from 4 years ago. The ESA Business Incubation Center program in Germany contributed to this success with 798 million euro in venture capital raised by former ESA Big alumni in the last years. This program initiated the new space scene in Germany with its growing number of private investments. Ladies and gentlemen, CESA and AZO manage the ESA Big program in Germany on behalf of public and private stakeholders. In total, 334 new ventures have been supported at 7 ESA Big locations in Germany, with an annual turnover of around 170 million euro in 2020, creating 3,800 direct high-tech jobs. This makes the German ESA Big program the most successful space incubator in Europe, in cooperation with well-known industrial and institutional players. The German success story shows that the new space industry is a job engine for local and regional economic development, and space-based services are an important driver in many industrial sectors. 2020 was the most successful year in venture capital investments in Germany. ESA Big alumni raised 442 million euros, almost $500 million in venture capital in Bavaria. This is close to 29% of the total venture capital volume in Bavaria last year. More than 40 venture capitalists from Germany and abroad participated in the 30 financing rounds. This shows the enormous interest in the German new space industry and the growth market in the commercial space industry. Investments in urban air mobility, robotics, artificial intelligence, small satellite launchers, or microsatellites underline the importance of space as an innovation driver for numerous industrial sectors. And this is a success story that is now taking place at numerous locations in Germany.
Thank you, Thorsten. I can confirm indeed that 2020 was also a successful year for the ESA Big locations in Hesse and Baden-Württemberg. On the next slide, we see a few examples of ESA Big companies that succeeded in raising substantial investments in 2020. They have been supported by CESA and our partners, the IHK in Reutlingen and Airbus in Friedrichshafen. But we are not alone. As on the next slide, you will see we are part of a growing network all over Europe. It consists of 22 ESA Bigs with more than 1,100 supported startups. Furthermore, a network of ESA business applications ambassadors and ESA technology brokers. In Germany, this is all funded by DLR and the regions. Together, we have built one of the largest ecosystems for space in the world. But let us now come to the ESA Big Challenge within the INNOspace Masters competition. The original focus of the ESA Big program is the support of entrepreneurs who apply space technologies in a non-space environment, thus so-called spin-offs. Today, and actually motivated by this challenge, we also take the reverse path and support space spin-ins as well. The ESA Big Startup Challenge was therefore again looking for innovative startup that focus on achieving substantial progress in space commercialization. And the winner of the ESA Big Startup Challenge will receive a support package tailored to the requirements for its realization. This is assistance in transforming the business concept into a viable business plan, support of the application in one of the German ESA Big facilities, and if accepted, you will benefit from 50,000 euro in funding. And last but not least, access to the Europe-wide network of experts which can assist in both technological and business-related aspects. And here are the winners of the ESA Big Challenge 2020-2021. And we will start with the third prize. I open the envelope. The third prize goes to Jorge Ramirez Miguel von JMP Engineers SL for Micro G-Scope. Congratulations.
Wow, fantastic. We got the third prize. Fantastic. Wow, that's unexpected. Thank you. Fantastic. Okay, I think I have it here. So, hey, here it is. So let me see. Wow. So I guess this is the third prize. Let me see you if you can see it perfectly. Okay, we got the third prize. Thank you very much. We are very grateful to all the team and to the judges for trusting in us. Thank you very much. We will put it to good use. Thank you very much. We will enjoy it.
And now we come to the second place in the ESA Big Challenge. It goes to Markus Witt from Metrum Mechatronische Maschinen GmbH with Sissi. Congratulations.
Thank you very much. We are very delighted. Thank you.
And now we come to the winner of the ESA Big Challenge in the INNOspace Masters. It goes to Katarina Ostaszewski from Phisens GmbH und TU Braunschweig for an intelligent system maintenance and current monitoring. Congratulations to this success.
we are very happy to have won the first prize in the ESA Big challenge. Thank you to everyone who has supported us on our journey. Thanks.
Thank you all and congratulations to the ESA winners. And now, ladies and gentlemen, it's time for the Airbus Challenge. It's next. 3 creative ideas waiting to be awarded. Andreas Lindenthal, Head of Business Operations Space Systems at Airbus Defence and Space, will open the envelopes.
Thank you very much, Klaus. INNOspace Masters 2021. Innovations for sustainable infrastructure in space and on Earth. For Airbus, a company which is pioneering the future for a safer world, the sustainability of infrastructure in space and on Earth is a key topic. Therefore, we are very glad that we are able to contribute to this contest, where many people were providing their ideas, a lot of innovations we had to assess, we had to recognize and to acknowledge. And I would like to start by saying thank you very much to everybody who was providing their ideas. And thank you very much for your innovations, for your passion, for your engagement. We had a lot of brilliant ideas, and I'm pretty sure that we will see many of them in the future being implemented in startups or in programs somewhere, and looking forward to see that happening. And there is no contest without a winner. Therefore, I would like to come to the top 3 innovations as we have assessed that, and would like to give you an insight which are, in our view, these innovations. And I would like to start with number 3, the 3rd place in this year's contest of INNOspace Masters, which goes to Alreco, Frank Koch and Orbit Recycling. Congratulations.
Many thanks to Airbus for selecting my unconventional submission. I'm very proud of this. Thank you so much.
And the 2nd place this year goes to Versatile Approach for Cloudless Optical Satellite Data, Morten Fjord Pedersen and Clear Sky Vision. Congratulations.
Thank you for this opportunity and taking the time to recognize us. It's always a help as a startup for sure. Thank you.
And now the winner of this year's competition is DigiFarm. Niels Helset, Konstantin Varik for DigiFarm AS. Congratulations and good luck for you for the future. Thank you very much.
Oh, wow. Absolutely amazing. That's incredible. Thank you so much. Yay. It's absolutely incredible. Thank you so much for me. It's been absolute honor. Thank you.
Again, my sincerest thanks to everybody who was contributing this year. Looking forward to see you next year in the INNOspace Masters 2022. Thank you very much.
Thank you, Andreas Lindenthal, and all the best to your winners. Another familiar face in the community, Lutz Bertling, Chief Strategy and Development and Chief Digital Officer from the Management Board at OHB Group. Here is his praise for the great ideas from the OHB Challenge.
Good day and welcome to the INNOspace community. I'm very happy to be able to present to you, unfortunately only virtually, the winners of the OHB Challenge within INNOspace Masters. Global trends like the fight against climate change, like a growing overpopulation, like the need for connectivity everywhere on Earth for many different purposes, are fostering, are increasing the need for space-based assets and for space-based applications. In these circumstances, we have to deal with certain particular aspects. We have to deal with the overpopulation of space itself, in particular in low Earth orbit in the LEO area, where more and more satellites are already on orbit and thousands to come. We need to deal with sustainability and efficiency and greener space. We need to deal with space business itself becoming very efficient, very sustainable, and not a challenge for the climate itself. We need to come to new, to innovative solutions. We need to be faster, we need to be more agile, we need to be more efficient, we need to be cheaper in solutions which we provide. We at OHB, we are very much involved in all these topics, in international and national, institutional and private projects. We are very proud to be in CO2M, in CIMRE, in CHIME on European level, in PRISMA, and NMAP on national level in Italy and Germany. We believe a lot in the contribution of, for example, hyperspectral Earth observation, and we believe that here we have a strong position which we are dealing with. But then we have a second aspect. We have an aspect which is bringing new creativity, new ideas, new concepts to the space business. Now, in addition to what we are doing, INNOspace Masters brings an important additional aspect. It brings creativity, it brings out-of-the-box thinking, it brings innovation, it brings fresh impulses for us. And we are proud to be able to support such initiatives. They're coming from single person, from teams, from startups, wherever they are. We want to encourage such contributions. We want to encourage them as a means to support society, but as well for ourselves to get fresh impulses from the outside. And I'm particularly proud that the three winners we have are dealing with three areas which, from my point of view, are very important for the future of space. And this is greener space, this is the usage of Earth observation data. I spoke already about the importance of Earth observation data for dealing with climate change and so on. And it's with dealing with greener space itself, which means cleaning up not only Earth, but cleaning up space as well. And these are the areas where our winners are coming from. And now let's see who gets the third prize. Let's deal with the envelope. It's always interesting. And the third prize goes to Ignatiy Romanov-Chernigovsky for the idea DLTEO, a one-stop shop for Earth observation data. My congratulations.
Yes, I'd like to thank OHB and INNOspace for organizing this event. It has been quite an interesting journey to get this far, and we're very happy to have reached the award ceremony and to have found this amount of reception for our project. Thank you very much once again.
So we are coming to the second prize of the OHB challenge. Let's see who that is. The second prize goes to Christian Stamper for his idea Sustainable Spacecraft Propulsion by Walther as the expellent mass. Congratulations.
Ja, danke. Thank you very much. Great one. Thank you. Thanks to my wife, Imke, and my both daughters, Eliana and Lunea, for making this possible.
And finally, the first prize of the OHB Challenge 2021. The first place goes to Niklas Wendel and the team of the German network of young scientists for their idea, Debris, cleaning space at scale. Special congratulations and first prize to you.
Amazing. Thank you very much. That's an amazing accomplishment. Also, thanks a lot to our team, which made this accomplishment possible.
Congratulations to you all. Thanks, Lutz Bertling of OHB. One more set of envelopes to go. Christian Weiland, Chief Technology Officer at DB Netz AG, will announce who will score the first, the second, and the third prize at the DB Netz AG Challenge.
Ladies and gentlemen, I'm very glad to be here. After last year's success, I'm again very happy with DB Netz being a part of the INNOspace Masters Challenge this year. As Europe's biggest infrastructure provider, we are currently laying the foundation for complete modernization and digitalization of the railway infrastructure. With the rollout of the European Train Control System and digital interlocking systems, and in the integrated control and operating system, the entire command and control technology will be renewed by 2035. In order to know what's going on outside, we need a lot of sensor surveillance as constantly and precise as possible to operate our trains in some different automatic train operation modes. Of course, a reliable infrastructure built from bridges, tunnels, and railway systems themselves, this will be in a large amount of data that we'll have to monitor in order to control the health of our infrastructure in real time. With this sensor-driven approach to monitor our infrastructure, technical devices, and everything else that makes up our railroad system, we see parallels with the space industry, where tons of data are produced daily. Definitely one of the parallels of the space industry with the railway industry. Digitalization, automation, and artificial intelligence are keys to a higher capacity and optimal utilization of the railway network. Our goal is clear: more attractive rail transport with more trains of higher quality. And all of this without adding a single meter of new track. This is the way we aim to reach a transport turning point. Twice as many passengers on the railways and increased freight traffic by 2030. Thus, Digitale Schiene benefits both our customers and climate. The railway will once again become a high-tech industry, with attractive jobs and innovation strength in Germany and beyond. With this in mind, we are happy to announce the 3 winning approaches of the DB Netz Challenge. Thank you very much. So let's come to our winners. The third, I'm delighted to announce Electra Solar ranked 3rd. They are monitoring traffic routes by a solar electric powered ultralight aircraft and with an innovative multi-user 3D capturing and processing technology. Congratulations to Professor Florian Siegert, Dr. Sven Schmidt, 3D reality maps, and Electra Solar. Congratulations.
Super. Great. Thank you very much to the jury and the Galileo Masters team. Thank you also to our team members that participated in that project.
Now the second winner. Placed second, with a very interesting AI-powered aerial image analysis, enabling continuous monitoring of infrastructure and preventative maintenance, a company from Japan. Congratulations to Harakus and Adrian Sosna.
Wow! Thank you so much for
this recognition and this award. I will say for all of Hackers that we're very excited that the efforts that we're putting in building smarter solutions is getting this type of recognition. And I really look forward to continuing exploring ways of working with DB and in the field of space.
And now the winner. The winner of the DB Netz Challenge is a highly interesting approach towards monitoring our rail infrastructure with magnetic sensors. We are already in touch with them and currently planning a first pilot project. The winner is Phisons with Henriette Struckmann from Braunschweig University. Congratulations.
Very happy to win this prize. And we would really like to thank Kai Illmann and the Tourismus- and Warentreibahn GmbH for providing us the access to the necessary infrastructure and inside knowledge of rail systems. Möchte ich auch noch was sagen?
Thank you.
Thanks.
The second win for Phisons this afternoon. Congratulations and thank you, Christian Weiland. And thank you, all participants. Thank you for all those innovative concepts, especially these last ones that link rail and space. Now, we know all the winners, all the scores, except for one. The highest honors at the INNOspace Awards ceremony go to the overall winner. And here is the best person to present and praise the overall winner of the 2021 INNOspace Masters Awards. Thomas Jarzombek, coordinator of German aerospace policy in the federal government. He holds that final envelope.
So now we come to the highlight of today to present the overall winner. And so I have an envelope here. And let's see who made it for this year's challenge. So, INNOspace Masters 2021, the overall winner is, ta-da! Henriette Struckmann, Philipp Heinisch, and Katharina Ostatsiewski from Phisons GmbH, a spin-off company of the Institute of Geophysics and Extraterrestrial Physics of the Technical University in Braunschweig, with their idea, Intelligent Systems Maintenance and Current Monitoring. So, my congratulations and all the best, and I want to see your success.
We are very honored to be the overall winner of the INNOspace Masters Competition 2021. This would not have been possible without the amazing support from the team of the Institute of Geophysics and Extraterrestrial Physics from the TU Braunschweig.
Especially, we would like to thank Professor Karl-Heinz Glasmayer, who is one of the principal investigators of the Rosetta mission, Professor Andreas Hört and Professor Jürgen Blum for the outstanding support, the continuous mentoring and the fruitful scientific discussions.
And we would also like to thank the entire ESA team for making such ambitious missions like Rosetta possible in the first place and provide the opportunity for technologies like this to be developed.
Congratulations. Didn't I mention Rosetta in my opening remarks as a mission with a significant delay, like our award ceremony? And good things still come from it. Inspiration for our overall winner. What a wonderful success to celebrate tonight for the Phisons team, winner of the DB Netz AG Challenge, winner of the ESA Big Challenge, and overall winner. Congratulations. Katharina, what does this mean to you to be so successful tonight? What significance has the INNOspace Masters Award for you and as well as for other innovative minds?
Hi. We are very honored to win these 3 awards at the INNOspace Masters competition this year. As INNOspace Masters is a well-established international competition for scientific and space technology related topics, which supports new ideas for sustainable infrastructure in space and on Earth, we feel very proud to be chosen as this year's overall winner. INNOspace Masters provides a great opportunity for research institutions, universities, and startups like us to present their innovative ideas at an early stage to a wide audience of leading industry and scientific experts. Our fellow participants presented outstanding and interesting projects and ideas for future innovations. We are deeply humbled to be part of this exciting community. Besides this, the competition made it possible to get in touch with established institutions and partners. It gives us a chance to receive support, get directly in touch with respected experts, or enter a joint test phase, which would have been impossible without the INNOspace Masters. This makes it easier for startups like us to enter new markets. And this highlights the great potential of space science at the aerospace industry to shape the innovations of tomorrow.
Katarina Ostasewski of Phisons. Congratulations again. Well, this was the INNOspace Masters Conference and Award Ceremony for this year, another virtual version, but with a lot to celebrate, even if not in the same room together. Hopefully 2022 will bring that back. Good luck once again to all the winners. Congratulations also for embracing that ever-important concept of sustainability in your innovation. Thank you. And thank you for watching. Keep being inspired.